Hello, so today we're going to be covering our last chapter in quadratic equations, which is going to be proofs involving quadratic equations. And now this is our first example. It says that if the roots of this equation differ by 2, show that this is equals to that. So we're going to say that these proofs have a certain flow that they take. Now the first thing, we always have to let the roots, that's if the question has not already let for you, be alpha and beta. Now remember we talked about, I hope you've watched our video on the roots of quadratic equation where we talked about that if you have a standard equation like this, the sum will always be negative b out of a and the product will always be c out of a. So now here I'll come and say what is the sum. This is going to be negative 2p out of a, which is 1. So this is equation 1. Then the product of the roots will be c out of a, but here our c is q and a is 1. So this is equation 2. Now equation 3, I'll obtain it from the question, because the question has told us that the roots of the equation differ by 2. So alpha minus beta is 2. So I call this equation 3. Now I'm going to use knowledge of simultaneous equations. So using equation 1 and 3, where do I have alpha plus beta is equals to negative 2p. Then I have alpha minus beta, I have this is equals to 2. Now I add. Now when I'm adding from elimination method of solving simultaneous equations, when I add, I'm going to be eliminating beta. So here I have 2 alpha is going to be negative 2p plus 2. So alpha is equals to negative p plus 1. So we note that. Then now we also still using 1 and 2. This time we eliminate alpha and get beta. So here do I have alpha plus beta is equals to negative 2p, and then alpha minus beta is equals to 2. I have this, so I subtract. Alpha minus alpha is 0. Beta minus beta, this becomes 2 beta is equals to negative 2p minus 2. So what is beta? Beta is negative p minus 1. So I can call this equation T, and maybe this equation. Now you can label them anyhow. I just label them for the organization. So now I can say substituting equation tick and double tick into equation 2 from up here. So what was our equation 2? Equation 2 was alpha beta is equals to q. But what is alpha? Negative p plus 1 into negative p minus 1 is equals to q. So here when you open brackets, this becomes negative p into negative p minus 1 plus 1 into negative p minus 1 is equals to q. So this is p squared plus negative plus p minus 1 is equals to q. So what do we have? We have p squared, and then this, the p minus p goes, so I have minus 1 is equals to q. P squared is equals to q plus 1. I can rearrange it to look like how it is in the question. So we've proved that. Let's see another number. So here they're saying prove that if the difference between the roots is 1, then this is this. So we always first let the roots be alpha and beta. So from the sum, alpha will be, the sum will be negative b out of a, then the product will be c out of a. Then what is the question telling us? That the difference between the roots is 1. So alpha minus beta is 1, the difference between alpha and beta. Then we can call this equation 3. So this is very similar to the one we've just done. So we say using 1 and 3. So this is, let me underline this. So this is alpha plus beta is equals to negative b out of a. Alpha minus beta is equals to 1. So if I add, I get 2 alpha, this goes, is equals to negative this plus 1. So I simplify this. This is negative b plus this. So finally alpha will be negative b plus a out of 2a. Then I also come and say, still using 1 and 3, but this time I'm going to be eliminating something else. So this time I subtract. So alpha minus alpha goes. Now beta minus beta. So this becomes 2 beta is equals to negative b out of a minus 1. So what is 2 beta is equals to negative b minus a out of A, beta is equals to negative B minus A out of 2A. So maybe call this equation tick, call this equation double tick. So come and say substituting tick and double tick into 2. So 2 is alpha, beta is equals to C out of A. So this is negative B plus A, plus A, here is 2A into negative B minus A to A is equals to C out of A. So what does this mean? This is negative B plus A into negative B minus A. Here we have 2A into 2A. This is equals to C out of A. So opening this bracket, this is negative B into negative B minus A plus A into negative B minus A out of 4A squared is equals to C out of A. So here what do I have on opening brackets? This becomes B squared plus AB minus AB minus A squared out of 4A squared is equals to C out of A. So this and this goes, I can choose to multiply through by 4A squared. So this times 4A squared and then this side times 4A squared. So this and this goes, then this goes with 1A. So what do I have? B squared minus A squared is equals to 4AC. Then now I look at my proof. You just rearrange this and this will be A squared is equals to B squared minus 4AC, and we've proved that. Okay, so now we're going to look at this. This question says given that the equations y squared plus py plus q is equals to 0 and these have a common root, show that q minus k squared is equals to m minus p into this. Now for the equations that are going to be talking about common roots, we are going to always say let the common root of these two quadratics be y1. And what do they mean by common root? The first thing you know that a root of a quadratic equation is that number, or like that value that solves that quadratic equation. That means when you substitute that value into that quadratic equation, it's going to solve it. And since quadratic equations, the highest power is 2, they're going to have 2 roots. So here we would let, and because of time, I'm going to pause this video, then I'll play it when I've worked it out and I explain how I've done it. Sorry, alright, so here we are. So we said let the common root be y1, and after letting the common root be y1, you substitute y1 into these two equations. So then you have these. So the first part we are going to eliminate y1 squared, so we just subtract. We're lucky that the coefficient of y1 squared is the same, so we just subtract. So this is 0, then we say here plus p minus m into y1 plus q minus k is equals to 0. So what is y1? y1 becomes, take this side, this becomes negative q minus k out of p minus m. And this will be, because now here, the first thing we do here before choosing whether to take the negative up here or down, we look at our question. We have q minus k, here it's q minus k, so we would not want to change this. But down we have p minus m, but in our question we have m minus p. So we take the negative down here such that this becomes m minus p, since it's what we have in our question. So this is our equation 1. Then the second thing, we would want to now rewrite the equation, but this time we want to eliminate y1 here. We want to eliminate y1 here. But we look at the coefficients of y1, they are not the same. So we come and say what's the coefficient of y1 here, p. What's the coefficient of y1 here, m. So we cross, we multiply m by everything up, multiply everything down by p. So this is what we did here. Now we have m y1 plus this. Then now we subtract. Now when we subtract, this becomes m minus p into y1 squared plus this goes with this. Then we have plus mq minus pk. We take this side. So y1 squared is equals to this. Now when we have this, what are we going to say? We're going to say, we look at what do we have here, mq minus pk, but here we have pk minus mq. So we take the negative in, then we have this as our y1 squared. But remember, this is y1. So meaning if you square this, it will be y1 squared. So we squared this. That's how we have come. That's why we come here. We have q minus k squared out of m. So we squared this is equals to this. Then we multiply through by m minus p squared. Then we would have proved. If you have any questions, you can ask. So the next question is going to follow a similar pattern. So okay, so this question, given that equations this have a common root, show that b minus 1 squared is equals to this. We are going to use the same approach as the previous question, and I'm going to pause the video, and you can also pause the video, try it out, then play and see how we're going to do it. Okay, so here we are. So we let the common root be x1 like we did last time, but you said it was y1. Then we substitute. First eliminate x1 squared, or we make x1 the subject. This is what we get. Then we eliminate x1 this time, and this time we want to eliminate x1. We see what's the coefficient of x1 here, a. What's the coefficient of x1 here, 1. We cross them, we get this, we subtract, we make x1 squared the subject, and yeah, this is how we solve this. So let's look at another example. Given that the roots of the quadratic equation, these are in a ratio of 8 to 1, show that a squared, show that it's this. So the first thing we always say, let the roots be alpha and beta. So the first thing, what is the sum of roots alpha plus beta? This will be negative q out of p. Call this equation 1. What's the product of the roots? It's c out of p. Call this equation 2. Then the question has told us that they are in a ratio of 8 to 1. So alpha out of beta is equals to a to 1. So what's alpha? Alpha is equals to a beta. We call this equation 3. So we're going to substitute equation 3 into 1, and we also substitute equation 3 into 2. So what is 1? 1 is alpha plus beta is equals to negative q out of p. But what is alpha? A beta plus beta is equals to negative q out of p. So what do we get? We have beta into a plus 1 is equals to negative q out of p. So beta is equals to negative q out of p into a plus 1. Then now we come here. This was equation 2. But what is alpha? A beta into beta is equals to this. So we get a beta squared is equals to c out of p. So beta squared is equals to c out of a p. So we call this equation double tick. We call this equation tick. Then now we can say substituting beta. So we now, we shall say negative q out of p, a plus 1. We square this is equals to c out of ap. So what do we have? Q squared out of p squared. This is a plus 1 squared is equals to c ap. So here what do? We cross multiply. So what will you have? Q squared ap is equals to c p squared a plus 1 squared. Now at this point you look in the question, what do we have? An a squared, but here we don't have any a squared. So what do? We open this bracket. But before opening this bracket, we can divide through by p. So this p goes with this p. This goes. So we have q squared a is equals to cp a plus 1 squared. So because of space, I'm going to continue with this, and you will see how we came up with that. Okay, so here we are. So you see, we expanded a squared plus 2a plus 1. Then after expanding, we collect like terms, and eventually we come up with this.